Hello everyone, this is Mr. 13 Things, Silence It Good, or Papa, if you would. Coming at you talking in our third in a series of what you learn when you learn to run your calculator, specifically the TI-83. It's a lot more than running a calculator, which is why it should not be left to the purview of just the math class. And we use the TI-83 for a number of great reasons. The programming language isn't all that great, but it's out there and it's allowable on the ACT test. So we're going to try to do this one quickly today. One of the things you want to do when you turn it on, of course, is to turn it on and then ask it a question you know the answer to. And of course, that we've learned long ago is the tangent of 45. When you think it's degrees, it should be 1, but it's not. So obviously that takes you to the mode and you double check that your settings are all set. But what are you doing when you're setting settings? You're changing the state of the system. You are setting a bunch of variables. So in this case, radians, we'll change that, leave that as radians. And the next one, we want it to be a parametric set of equations. I'm hitting enter here, and so on and so forth. You're changing the state. Second, quit. And then when you go here and you go to the window, when you have things set up, you are changing the state. And now you start to see these variables. The state of the variables are summarized here. So the state of the variable, that's t min, is 0. T max, that's 2 pi, for those of you who don't recognize it. The t step, these are variables. You are changing the state of the variables. So when you go about doing that, you ask it a question. Once again, we talked about clear. I'm going to go second, quit a lot. Putting in a graph that you know the answer to, x equals t and y equals t, parametric equations here, and doing the graph and realizing that's not at 45. Once again, then changing the state of the variables that are defined in the zoom window. I'm going to go down here. If I go down with this one, I'm going to go to zoom square. And now all of a sudden you see a 45-degree line that goes from some distances, but that's 45. You want to make sure that you draw a picture you know the answer to. And finally, once again, the other pencil you know the answer to is the sine, hopefully the cosine of t, closing parentheses as a good habit, and the sine of t, closing parentheses is a good habit. One of the great things about this xt theta n is it kind of, depending what mode you're in, it kind of puts in what's the most obvious variable you want. If you're in a typical function mode, it's going to put in x, a parametric row t, theta if you are in a polar mode. So now when I say graph, and you can see that circle, and you're doing this so you're checking the visual affinity, or the aspect ratio here is indeed correct, so you do not untrain your eye. That's all said. We've talked about variables, so I'm going to hit again now clear, which is not necessarily, there it is, clear. And how we generally set variables in this computer is you go ahead and have 3 types of variables. Standard variables, which would be things for like real and integers, lists, and matrices, but more on that later. So if we're going to put 45, for instance, into the variable a for angle, right? Now when we say tangent of alpha a, close parentheses, it's going to give it the answer we expect. And again, we're running now in radians, so we're kind of okay with that 1.61, mostly because it reminds us how many kilometers are in a mile, or more importantly, perhaps the golden ratio, something like that. Square root of 5 plus 1 over 2, or the average of the square root of 5 and 1. And of course, these things may not mean much to you, but they should if you're at the point of learning how your calculator works. So where are all the important variables stored? Right there in the var. So when you hit that, they are stored again in a set of cascading lists. You have the kind of the variables that are stored there in the y function, and so this is a way for you to grab what's coming out of your kind of function definition there. So those are those variables, and unfortunately with this program, that's how you have to grab things. So this is not a great place to really learn how to program. Go out to www.code.org, Khan Academy, PHP Coder, all kinds of different places out there that are teaching you how to code. But we do want to learn how to use this because it is allowed, and it's a nice system to kind of acclimate yourself to programming. Mathematica is even a better one, but it's not allowed on the ACT test. So second quit. Once again, to go to variables, and you have then the ones I pointed out before, window variables. If I hit that, you have a set of x-min. And so if you wanted to go x-min, there it is. But most likely what you want to do is, for instance, say minus 100 or 111, store it into variables window x-min. And now if you look here in window, you can see that x-min is set to that. So you access all the state variables for the most part that are not defined by you by going, again, a lot of second quit, by going to variables. You have all kinds of different databases. So you have a set of string variables. The one I'm going to point out is statistics is another one. A lot of people doing this. And you have all these different variables that you can set or access, at least the definitions or the symbology for them. So if you wanted to, you know, basically if I hit that, let's see what happens. That gets me that. And at this point it's an error because I haven't done anything with them. All right, so you get at the variables there, and they're in cascading lists. The important ones you're going to see are going to be the window. I think the zoom one might be interesting. All these kind of different variables are stored in cascading lists. I always go all the way out. You can probably go up the tree. Don't know how to do it. Variables, graphic database, picture variables, string variables. And so this, once again, this is a weird one because it only allows you, it looks like, 10 string variables. So for instance, knowing that that's there, I can now, here the double quotes, I can say alpha, and then I'm going to go my name, alpha SD, where's S? Silence. QRS. And I apologize, this doesn't really read that well, but I think running along with your own calculator, this is how it captures and comes up. There are other ways to go about capturing and enlarging. SDW, SD wins. I'm going to go alpha here. One thing you're going to see, and I'm going to store that once again, variables into string, and then string 1. Right? And so now if I were to grab second variables, second quit, variables, string 1, I've actually, clear that, delete that, and hit a return here. It brings back what was stored in that variable. So to review, first thing you do is you ask it a question. And that's a way pretty much to get you to put and think about setting the mode and understanding what these things are. A big thing will be often that you haven't set it to float or that you have enough decimal places, and on an exam that can really throw you off. For sure, understanding whether you're running in radians and degrees is much larger than just a specific test. You've got to know whether you are dealing in the Babylonian degree system, which is all around us, or the true radian system, where 2 pi is a full revolution. Understanding whether you're running in a function, you're going to do your graphs in the function format, standard function format, parametric, polar, or sequential, and then lots of more stuff down here, how you're going to deal with complex numbers. And whether you're just going to be dealing in a real set of numbers, whether you're going to be dealing with a complex in the standard A plus BI format or in the polar format. So these are all things that you set here in the mode. You ask it a question. Again, we're in radians here, so we're going to hit second quit. And we can say, I don't know, what is the tangent of, then you get a little tricky on yourself, the tangent of second pi. That's wrong. Where is pi? Second pi over 2. And then you start thinking, that's the tangent 90 degrees. That should be infinity. Oh, there you go. An error in the domain. So instead, you might say, well, I don't know, maybe this doesn't have secant functions and all that on there. We will say instead the cosine of pi over 2 and you start to fill yourself in and keep asking it a question you know the answer to. And sometimes you start to expand those questions out from the one you typically are going to know, which is the 45. That's the best one to know to start. The tangent of 45 degrees is 1. The tangent of pi over 4 radians, that is 1. Understanding you do that, understand that you make sure that you have your settings set so when you graph something, it shows up the way it's supposed to. Once again, we've changed some of our settings there. So window, zoom, we can go zoom square. I'm going down to here. You know, really getting used to that. And later on, you're going to see that's going to be important. It's going to be set up by learning to use this next one, which we'll talk about, is the set of program variables. This is where you can store a lot of states of your calculator in one specific thing. However, in this program, which is the TI emulator, you can also store some state variables by just going here, and I'll end with that by saying you've got a calculator all set up the way you like it on here. Again, never rely on this because in an exam they're going to always kind of reboot your calculator and have to reprogramming it if you would. So you can actually go here and save as and save the calculator in the state it is and go from there. So I'm going to hit that. It's saved. Close that out, and thank you all for listening. Remember, you can put this twice as fast when it's on YouTube. Thanks for listening.